Hi dear students, today we will learn about the covalent bond. In our previous lecture, we have discussed about ionic bond and we have also discussed why atoms make bond. And in this lecture, we will try to understand the concept of covalent bond and its types. I will try to give some examples of covalent compounds, how these are formed. First of all, we come to our topic that is covalent bond. In our previous lecture, we have discussed why atoms make bond. We have replied that the atoms make bond to complete their octets, to get electronic configuration of their nearest noble gas, and to stable themselves. And today in this lecture, we will try to understand the concept of covalent bond according to Lewis concept. First of all, we define the covalent bond in a very simple way. We can say a bond formed by mutual sharing of electrons between two atoms is called covalent bond. In this bond, two atoms come close to themselves and they mutually share electron to complete their duplets or octets. Like in the examples, we can write as H2, O2, N2, and so many other compounds like H2O, like CO2, like CH4. All these compounds contain covalent bond between their atoms. And now we explain how these covalent compounds are formed by mutual sharing of electrons between their bonded atoms. First of all, we write their types. In first, we can write as single covalent bond, and then we will discuss about other type, double covalent bond and triple covalent bond. First of all, we define single covalent bond. Like the word single, it tells how this bond is formed between two electrons. We can define this bond in two ways. We can write as the bond formed by mutual sharing of one electron pair between two bonded atoms. One electron pair between two atoms. And now in this single bond, covalent bond, the bond is formed by mutual sharing of one electron pair between two atoms. In other words, we can also tell as the bond formed by mutual sharing of one electron pair in which each atom provides one electron. And one bond pair is formed between two atoms, and these two atoms attract that bond pair and come close to each other to form a single covalent bond. We can explain this single covalent bond in various examples. First of all, I will give the simple example of formation of H2. This is very simple covalent molecule. How this molecule is formed, we will try to understand the single covalent bond concept by giving an example of H2 molecule. First of all, to explain the bond formed between H2, we have to know about the electronic configuration of H atom. We know that H atom contains one electron and its electronic configuration is 1s1. In other words, we can say that there is only one electron present in S section of hydrogen atom. I can draw its atomic structure like this. This is nucleus and cation. It contains one electron. If I express it with the help of dot, this is one single hydrogen atom. And you know that hydrogen atom has only one electron. It tries to get two electrons in its outermost K shell to attain its nearest noble gas like helium electronic configuration. It needs one electron. But dear students, you should have to remember when identical atoms Like the atoms which have same or nearly equal electronegativity values, when they come close to each other, then they will try to mutual sharing of electron rather to transfer of electron from one atom to another atom. Like in this example, two are identical atoms, they have same electronegativity values, both have the same trend to share of electron between them, because there is no capability of atom to lose or gain electron, because both have the same tendency to accept the electron. In other words, they have the same electronegativity values. Now this atom has one electron. If I express other atom, hydrogen atom, and I write as it has also one electron, 1 s 1. If I draw its structure like this has one electron present in Keshav, and I express it with help of cross. Now, when these two atoms come close to each other like this is one hydrogen atom. You can see my diagram, and I express the electron present in this atom with the help of dot like this. And now other atom is other hydrogen atom. Like this, when this atom come close to other atom like this, now I express the electron present in this atom with the help of cross. These come towards each other. When they come close to each other, they will share one electron. Each atom will provide one electron, and now our electron pair is formed between two hydrogen atoms. Like this, I can draw its structure like this. Dear students, you know this electron is expressed across and this electron is expressed back dot. Now these two hydrogen atoms has one common electron pair. You know this is common electron pair that is formed between two hydrogen atoms, and this electron pair is common for both atoms like this. If it is present for this atom, now its duplet is complete. And this is also common for this atom, and now this duplet is complete. Now the two atoms attract this electron pair, that is called one pair, and now the nuclei of both atoms attract this electron pair, and these atoms are bonded with each other, and in this way a single covalent bond is formed. I can write its structure like this, that hydrogen atom, and this is the electron pair that is formed due to the mutual sharing of one electron from each atom, and this bond is called single covalent bond. I can also express it with the help of single line between two atoms. Now we give some other example of this single covalent bond, and I can also draw different structures of atoms for this purpose. Now I will give the example of formation of F2 molecule like this. Now in this F2 molecule there is single covalent bond between two fluorine atoms. If I write the electronic configuration of fluorine, you know that fluorine atomic number is 9, 1s2, 2s2 and 2p5. And like other fluorine atom, this will also have the 7 electron in its outermost shell. If I draw electron its atomic structure, this is the duplex, K shell and L shell. Like you know, K shell contains 2 electrons and L shell contains these 7 electrons. If I express these electrons like with the help of cross, you know this is one fluorine atom, and you know it has 7 electrons, and we have learned every atom have a tendency to get 8 electrons in its outermost shell. Now it needs only 1 electron, but when similar atom, identical atom having the same electronegativity values come close to each other, they will have trend to mutual share of electron rather to transfer of electron. Like one fluorine atom, I can write another fluorine atom like this. This electronic configuration is that 1s2, 2s2 and 2p5. This will also have 7 electrons in its outermost L shell. Like this atom, it needs 1 electron to complete its octet to get its nearest noble electronic noble gas electronic configuration to stabilize themselves. Now I can express the number of electrons present in its outermost shell with the help of dot. Now this atom needs one electron, this needs one electron. When they come close to each other like this, they will have tendency to mutual sharing of one electron from each atom. I can write its structure as, you know, that this is one atom, fluorine atom, and it has one electron in its outermost shell, 7 electron. This will share this electron. Now other fluorine atom that is present near it, this will also have to share one electron like this. This is other atom, fluorine atom, and this nucleus and its cation. This fluorine atom will share one electron. Dear students, you can see that both fluorine atoms mutually share one electron. Each atom provides one electron. One electron from this atom and one electron from that atom. Now one bond here is formed between two atoms. This is common for both. Like if it is present for this, it will have 2, 4, 6 and 8 electron. If it is present for this atom, 2, 4, 6 and 8 electron. Now the octets of both atoms are completed and they will bond with each other with the help of this chemical force, in which each nucleus of the atom attracts this electron here. This is called single covalent bond. And I can write it as one fluorine atom and its electron are represented by cross like this, and this is other fluorine atom, and outermost electron are represented by dot. This is the bond pair formed between two atoms, and I can also write it as fluorine atom is singly bonded with other fluorine atom. And I can give some other example of this bond like formation of methane. Formation of methane, you know that methane CH4 is very important organic compound, and in this compound there is single covalent bond between carbon and hydrogen atoms. If I write the structure of this molecule of form, I can write carbon and electronic configuration 1s2, 2s2 and 2p2. You can see that there are 4 electrons present in outermost shell of carbon. If I draw its structure of atom like this is nucleus, K shell, and that is its L shell, that is its outermost shell. It contains like this 4 electrons. This is the structure of carbon atom. Dear students, you can see its octet is not complete. It needs 4 electrons to complete its octet. But other atoms that form make bond with carbon, that is hydrogen, and you know hydrogen has only 1 electron. If I write its structure like this electron is present in its outermost shell, it's called K shell. Now what happens? One carbon atom make 4 single bond with 4 hydrogen atoms. If I draw its structure, I can write as this is carbon atom, and it contains 4 electrons in its outermost shell. 1, 2, 3 and 4. One hydrogen atom come close to this carbon atom like this. This will have tendency to share 1 electron like this. That is. And there is other hydrogen atom that will make bond with this carbon atom like this, and it will also share 1 electron like this. And now the third hydrogen atom come close and it share 1 electron. That is the 4th hydrogen atom that makes bond with carbon. Here students, you can see that 4 hydrogen atoms provide one electron to make 4 single bond with hydrogen atom, like carbon atom like this. This is carbon atom and these are 4 hydrogen atoms. And there are from 4 single covalent bond. Why? Because both atoms provide 1 electron and there is 1 bond pair between 2 atoms. And the bond formed by mutual sharing of one bond pair between two atoms is called single bond. I can write it as this is carbon, and if I express the electron of carbon with cross or dot and electron of hydrogen with cross, then you can write as this is the methane molecule, and which is formed by mutual sharing of one electron pair between carbon and four hydrogen atoms, like this. Now we move toward our second type of bond in covalent case, that is called double covalent bond. Like this, what is double covalent bond, and we will explain it with the example of various covalent compound. Dear students, first of all, we need to define double covalent bond. Like single covalent bond, we can define it as the bond formed by mutual sharing of two electron pairs between two bonded atoms. Now we have defined as if two bonded atoms mutually share two electron pairs. In other words, if there are present two bond pairs between two bonded atoms, this bond will be called double covalent bond. In simple way, I can tell as the bond formed by mutual sharing of electron in this way. Each atom provides two electrons. As a result, 4 electrons will become between two atoms, and in other words, two bond pairs will be formed. This bond is represented by two small lines between two bonded atoms. If I give example like this, formation of bond between two oxygen atoms or formation of O2 molecule, and in other words, formation of ethene like this, and so many other examples can be given in this case. I will explain this double covalent bond with a suitable example of O2 formation. I can write the formation of O2 molecule, how O2 molecule is formed as a result of double covalent bond. Dear students, in order to understand the type of bond between two bonded atoms, first of all, we will have to move toward electronic configuration, and we will have to see how many electrons are present in the outermost shell of atom. Now we will imagine which type of bond will be formed. First of all, we write the electronic configuration of oxygen. You know that oxygen has atomic number 8. Its configuration is as 1s2, 2s2, and 2p4. You can see there are 6 electrons in the outermost shell of oxygen. If I draw its structure like this is nucleus, its first shell K shell, and then its outermost shell, the L shell. It contains 2 electrons, and it contains 6 electrons like this, 2, 4, and 6. It needs 2 electrons. And we can also imagine which type of bond will be formed. Because it needs 2 electrons, it will have the tendency to share 2 electrons with other oxygen atom in order to complete its octet and to get its nearest electronic configuration of global gas. Now, the other oxygen atom which make bond with this it also contains 6 electrons in its outermost shell. If I draw its structure and show the electron with the help of cross, you can see it has 6 electrons in its outermost shell. Now both atoms need 2 electrons to complete their orbits. When they come close to each other, they have to mutual share of 2 electrons. 2 electrons will be provided by this atom and 2 electrons will be provided by that atom. Like this. If I draw a structure like this, we can write as this is one oxygen atom, and because we know that in covalent bond only the outermost electron participate. This is one oxygen atom. There are 2 electrons which will be participate for formation of the covalent bond, and this is another oxygen atom, and it also have two electrons for this purpose. Like this, if I draw a structure like this, and it will provide two electrons for this purpose, and that are the electron provided by this atom. If I show electron of this atom by dot like this, now dear students, you can see there are four electrons between two oxygen atoms. In other words, two bond pair will be formed. This electron pair are common for both atoms. Like if this is for this atom, 4, 6 and 8, this octet is completed. And if this is for this atom, it will have 4, 6 and 8 atoms. Its octet will also completed. Now in this case, two oxygen atoms like this will be formed by mutual sharing of two electrons from each oxygen atom, and there will be formed a double covalent bond between two atoms. I can write it as this is double covalent bond and will be expressed with two small lines, and in this way the molecule of O2 is formed. Clear? Now we will move toward our last type of bond, that is called triple covalent bond. And first of all, we will have to explain it with example. Triple covalent bond, like single covalent bond, like double covalent bond, we can define the triple covalent bond in a very simple way. We can define it as the bond formed between two atoms, formed between two atoms by mutual sharing of three electron pair or bond pair, three electron pairs between two atoms. We can define triple covalent bond as the bond formed between two atoms by mutual sharing of three electron pairs, which are called bond pairs. In other words, we can define as the bond formed between two atoms in such a way that each atom provides three electrons. As a result, 6 electrons will be formed between two atoms, and there will be formed three bond pairs, like the example of N2, like the example of C2H2, and there is triple covalent bond in both carbon atom in acetylene. We have some simple example formation of N2. We will write how N2 molecule is formed, formation of N2. Dear students, in our other example, we have to understand that if we can tell about the type of bond will be formed between atom and a molecule, we will have to see electronic configuration, or we have to see how many electrons are present in the outermost shell of atom. Like in N2, now we have to see electronic configuration of nitrogen. Its atomic number is 7. I can write that as 1s2, 2s2 and 2p3. You can see that there are present 5 electrons in the outermost shell of nitrogen. If I draw its atomic structure, atoms, you can see that cation, and this is L shell, outermost shell of nitrogen, and it contains 5 electrons like this, 2, 2, 4 and 5. And now it needs 3 electrons. You can see that there are present 5 electrons, and it needs 3 electrons to complete the octet to get its nearest electronic configuration of the gas. If it comes toward other nitrogen atom, and it will also have like this 5 electrons in its outermost shell. Like this, it contains also 5 electrons in its outermost shell. This is other nitrogen atom. When these two atoms come close to each, then they will have to share 3 electrons from each atom, and there will be formed 3 bond pair between two atoms. Like this, if I draw its structure of formation of N2, I will write as this is the first atom of N2 and it will provide 3 electrons. This is the nucleus, this is the K shell, and the 2 electrons are present which will not participate for the formation of bond, and you know that is called lone pair of electron. And now this is the other nitrogen atom. It will also provide the 5 electron, 3 electron like this. These electrons are provided by other nitrogen atom, and they are common for both atoms. Like this, if I draw its electron with the help of dot like this is the other nitrogen atom. And now how we can see 3 electrons are provided by this atom and 3 electrons are given by this atom. There are 6 electrons. In other words, there is 6 electrons means 3 bonds get between 2 atoms. This is common for both atoms. If it is for this atom, 6 and 2, 8, its octet is complete. And if for this atom, 6 plus 2, 8 and its octet is complete. If I write this as nitrogen atom, it has 2 electrons which are not participated in bond formation. This is the other nitrogen atom. It has 2 electrons, and now there are 2 atoms are bonded with 3 single bond which is called as triple covalent bond. And how this molecule of N2 is formed. This is the last type of covalent bond which is called triple covalent bond, and in this bond each atom provides 3 electrons and there are 3 bond pairs between 2 bonded atoms. And in different examples, dear students, we have seen hereby some atoms, some electrons in the molecule cannot participate for bond formation. Like this example, 2 electrons are present on each nitrogen atom which have not participated in bond formation. This electron pair is called as lone pair of electrons. This is called lone pair of electron, and the electrons which have participated in bond formation are called bond pair of electron. There are 3 bond pair of electron and 1 lone pair of electron on each nitrogen atom which have not participated in the bond formation. Now in this topic we have learned about the covalent bond, how covalent bond is formed. We have explained its various types with suitable example of molecule, and now in next lecture we have tried to understand the concept of covalent covalent bond.